All right, guys, this morning we're going to do some more solving for x, and this weather has my voice crazy, so we're going to just do our best today. What we're going to do is, just like we have all week long, there's going to be several problems through here. We're going to just start at the very beginning and do a review walkthrough. You guys are going to work all of these problems just like we have all week. Every new slide, do the problems, pause the video, do the problems, and then turn it back on and check your work. And then send me your work. Text message me a picture of your work when you're all done. So we're going to back all the way up and start at the very beginning of what we did solving for x. So what I want you guys to do is I want you guys to work these two problems. These are very basic inverse things. The only thing you need to really pay attention to are your signs. So pause this, work them, and then come back and check them with me. All right, so guys, I'm going to work the left side first. So to help my brain, I'm going to draw a line here. Remember on this one, or on all of them, our job is to get x by itself. I need to pick this up, and I need to move it over the equal sign. Remember, when I do that, the operation changes. So I'm going to rewrite this. It becomes 17 minus 12. So x equals 5. Now listen, if you wanted to check this to see if it was right, let me do this in red. If you wanted to check it, all I would have to do is plug this 5 back in up here. And then see if I end up with an actual true statement. Is 5 plus 12 is 17. 17 equals 17 is true. If I did not end up with two numbers that were equal to themselves, then my answer would have been wrong. Okay, so that's just an easier, well, maybe not easier, but there's a way to check that. I'm sure that most of you would never do that for like your homework. I probably wouldn't either, but on a test, if you ever go take an SAT or a PSAT or a college entrance exam and you wanted to just check your work, you can always do it that way. All right, now this one we have to pay attention to on this one. We have to kind of pay attention to when we get to the end of this. So again, our first step is to get x by itself, so I have to pick this 14 up. Remember, no sign is an understood plus. So when I move that 14 over, I end up with 11 plus 14. The one thing you really have to pay attention is this right here. You don't lose that. You're not moving that yet, so keep that with your x. So negative x equals 25. Now my question is x all by itself yet? And the answer is no, because we have a negative in front of it. Now remember, technically, we have a negative understood 1. So what I have to do now is I have to get rid of that negative 1 there. Let me rewrite that so it's a little bit easier to read. So remember, some of you need to make sure you write those 1s in so you don't lose them. Others of you are fine. You know it's there. And the truth is you all know it's there. You just forget it when you're working with it. So now I'm going to have to move this negative 1. Well, I'm multiplying here. When I move it over, it becomes division. Remember, our last step is always to multiply or divide. And then that simplifies down to x equals negative 25. Okay, same thing here. Work these and then check them. Remember this, where's my pen? This is multiplication. Remember, a fraction line just means division. So give those a shot. All right, now I'm going to come back and I'm going to work these so you can check your work. By multiplying on this side, I'm going to move it over and it's going to become division. Now remember, the sign doesn't change, the operation changes. So what I'm going to do is I'm going to divide by negative 3. Now a whole lot of you are still making this mistake. Whatever you move goes second. This is not 3 divided by 27, it's 27 divided by negative 3. And I would suggest writing it as a fraction instead of this, because when a lot of these at this level are not going to simplify to a whole number, and you're going to have to leave it as a fraction, and this is hard to rewrite it as a fraction. So go ahead and write it top divided by bottom as a fraction form, and then you can reduce it. But whatever you move is going to go on the bottom. 27 divided by -3 is -9. And again, I can plug that back in here and see if it's the same thing, and 3 times -9 is -3 times -9. Goodness, sorry. -3 times -9 is +27. So that's the right answer. All right, on this one, remember fraction means division. So when I move that 7 over, division becomes multiplication. What am I doing here? Guys, my brain is not working. Here we go. When I move this over, I'm going to write it second, and we all know multiplication order doesn't matter. But in order to keep our brains used to it, go ahead and write it second. My voice is getting worse as I talk, I think. All right, 7 times 4 is 28, so x is 28. All right, let's go to the next one. All right, guys, then we moved on to two-step problems. So we'll give these a shot. Remember, x is to the left, numbers to the right. All right, now that you've had a chance to work these, because you paused the video and you worked them, let's work them together. X is to the left is the first step, already done. Everything else to the right, so I'm going to pick this up and I'm going to move it over. -24, I almost forgot my negative, plus 9. -24 plus 9. Different signs, we subtract. Keep the sign from the bigger number. Now I need to divide to get rid of my goodness. Now I need to divide to get rid of my 3 with that x. -15 divided by 3 is -5. And again, if I wanted to plug that in, oh gosh, that just went off my thing, but that's okay. If I wanted to plug this in here, I could check it. 3 times -5 is -15. -15 minus 9 is -24. Therefore, it's the right answer. All right, let's do this second one. X to the left, already done. Everything else to the right, so what I have is -4x equals -15 minus 45. -15 minus 45, they're the same sign because remember a negative and a minus are the same thing here. And I add and I keep the sign, so it's -60. Second step, I'm going to divide. Whatever I'm moving is going to go second. Don't change the sign, we only change the operation. And then -60 divided by -4, this one's going to simplify down to 15. And it's positive because a negative divided by a negative equals a positive. All right, then we got these even longer here. You're going to have to move a lot of things. You're going to have to move all your x's to the left, all your numbers to the right. All right, give this one a shot and then come back. All right, step 1, move all your x's to the left. So I'm going to move this one here. And I'm going to go ahead and do it in 2 steps. I know some of you don't, which is fine. I typically don't either, but I'm going to just write it all out so we can follow along step by step. Step 2, numbers to the right. 12x minus 9x equals 1 plus 14. And then remember, this 9x became a negative when I moved it because of the understood positive, okay? All right, so first step, x is to the left. Second step, numbers to the right. Third step, add any like terms. 12 minus 9 is 3. 1 plus 14 is 15. Remember, our last step is to always multiply or divide. More often than not, it's going to be division because at this point, you'll normally have, well, it doesn't matter why, but it's almost always division at this level. 15 divided by 3, x equals 5. And again, to check it, I could plug it in here, and I could plug it in here, and then solve the left side and solve the right side. And if those values are the same, then you did it correctly. The next thing we did was add in distributive property. Remember to distribute first, then add your like terms, and then you go into your x's to the left, numbers to the right stuff. So give this one a shot, and then come back and check it. All right. So remember, the walkthrough is order of operations. We always look inside of our parentheses. There's nothing we can do inside, so where are we going to look? We're going to look outside. Outside we have a -8. So make sure that you distribute the negative. So -8 times 7 is -56. -8 times -3 is +24. So that's one thing that some of you I've noticed are still kind of struggling on. Make sure that your 8 or whatever's on the outside goes to every piece inside. Make sure it hits the first one and the second one. Drawing those arrows like I do will help you remember to get everything touching. Okay? Now, we've done distributive property. We don't have any like terms at this point. So now we're going to go on to the next step. X is to the left. Already done. Everything else to the right. My -56 is going to become +56. And so now we're going to add our like terms. I don't have any like terms on the left, but I have like terms on the right. So I have 64 plus 56, which gives me 120, I think. Here, then, well, yes, 120. Last step is going to be to divide and make sure whatever you're moving goes on the bottom, and you end up with x equals 5. We just now are going to add in more distributive property. So try this one and then come back. All right, let's work this one. Operationally, we look inside of our parentheses. We can't do anything. And let me just reiterate that. Why can't we do anything in here? Why can't we do anything in there? And if we were all together, your answer would be because there's no like terms. So we're going to look outside. I'm going to distribute this 3 to both pieces. Then I'm going to distribute this 2 to both pieces. 3 times 3x is 9x. 3 times -1 is -3. 2 times 4x is 8x. 2 times 5 is 10. No like terms, so now we're going to move on to x's to the left, and I'm going to move this one here. At the same time, I'm going to move this one over here. My understood +8, I wrote a plus as I'm saying it, is going to become minus. My -3 is going to become plus. Now I do like terms. 9x minus 8x is 1x. I know you don't have to write the 1, but I went ahead and wrote it there so my brain can see it. And then technically my last step is to divide, and most of us would not need to write that out, but I know some of your brains will want to see that. So x is simply 13. All right, I think we have one more to do. Let's see. Well, I was wrong. We do not have another one to do. That's it for our quote-unquote in-class work. Send me a picture of your work of those problems, and then your homework is attached into your email that I sent this morning. All right, if you have any questions or if you need any help, send me a text message, FaceTime me, and we will go from there.